Okay, today in 6.3, we are working with the slope-intercept form of a line. Okay, so the slope-intercept form of the line is what we've been working with all along. Y equals mx plus b. Okay, slope-intercept because this is the slope and that is your y-intercept. Okay, so if we are given an equation that is not in that form, but we're told to write it in that form, that means simply solve for y. Okay, so for example 1, it says write 3x plus 2y equals 6 in slope-intercept form. What that means is, in other words, solve for y. Solve for y, right, in slope-intercept form. Okay, when they tell you to write in slope-intercept form, they are telling you solve the equation for y. In other words, get this y right here all by itself. Okay, so we can make that happen. We'll leave 2y where it is and subtract over the 3x. Now, in order to isolate the y, we are going to divide everything in the whole equation by 2. Everything. Okay, so y equals negative 3 over 2x plus 6 divided by 2 is 3. And from there, it says, then state the slope and the y-intercept. So the slope is the 3 over 2. It is not 3 over 2x or negative 3 over 2x. The slope is negative 3 over 2. The y-intercept is positive 3. So again, when it gives you a form of an equation, this is actually, this form right here is standard form, ax plus by equals c. Okay, that's the standard form. When you're given a form like this one here, and you're told to write it in slope-intercept form, again, that is the same thing as being told to solve that equation for y. Okay, so moving on to the next couple of examples, we've got example 2, graphing. Okay, now this is something that we have been doing all along, all the way from when we were trying to figure out equations for lines being given tables or points. Okay, we've done this all along, graphing from slope-intercept form. Graph y equals 1/2 x plus 4. Okay, this is y equals mx plus b. So 1/2 is your m and your y-intercept is 4. So remember, just a refresher, you start by plotting the y-intercept first. It's a positive 4, so we go up the y-axis 4 units and make a dot. And then from that dot, we have our slope. Okay, it's positive because both the 1 and the 2 are positive. So that means we will go up 1 and right 2 from that dot. So up 1, right 2, up 1, right 2. Or we could also go down 1 and left 2, because down 1 and left 2 is the same thing as negative divided by a negative, which is still a positive. So we can go down 1 and left 2 and still end up on the same line. Okay, so that would be our line, graphed y equals mx plus b. Always start with your y-intercept and go to incorporating your slope from that point. Okay, so having graphed from y equals mx plus b before, we're going to example 3. So this incorporates examples 1 and 2 together, okay? Because they want us to graph 2x plus 3y equals -3, okay? But the best way to do that is to solve this for y. So even though they did not tell you to write this equation in slope-intercept form, the best way to graph this is to get it into y equals mx plus b, which is the same thing as solving that equation for y. So we'll start with that first. We'll isolate the y term by moving over the x term to the other side by the -3. And then divide everything by 3. That gives us y equals -2/3 x minus 1. -3 divided by 3 there at the end. -3 divided by 3 is -1. Now this is our y equals mx plus b. Our slope is -2/3, and our b value, the y-intercept, is -1. So always start by plotting a -1 on the x-axis. Down 1 is -1. And then from there, our slope, we could either plot -2 over +3 or +2 over -3. We'll do both. Let's start with this one first. We'll go down 2 and right 3. Okay, and that's that point when we go down 2 and right 3. But let's now also do up 2 and left 3. So go back to your y-intercept, and we'll go up 2 and left 3, and that is that point. So again, it just proves that doesn't matter where your negative is, okay? You will still end up with a point on the same line in both cases, whether you put the negative with the 2 or the negative with the 3. Okay, so graphing a line that is not in y equals mx plus b form, the best way to graph that line is to get it into y equals mx plus b form, which is to solve it for y. Okay, now the next example goes back to understanding horizontal and vertical lines. Okay, perfectly horizontal lines are y equals lines. Okay, for example, y equals 3. That is a perfectly horizontal line through the y value of 3. So 1, 2, 3, and that is our line y equals 3. Likewise, we also had vertical lines, perfectly up and down. Those are x equals lines, okay? And for example, if we were graphing x equals -3, we would go to -3 on the x-axis. Whoops. Right here. There's -3. And we will draw a vertical line through -3, the x value of -3. So that's the next example, is just a reminder of how to graph. And let's review what those slopes are. Okay, remember, using the slope formula. I'm going to pick a point here and I'm going to pick a point here. The coordinates of this point are -2, 3, and the point here is 1, 3. So my slope formula, y2 minus y1 over x2 minus x1. Okay, so this is x1, y1, x2, y2. So y2 minus y1 over x2 minus x1 gives me 0 over 3. 0 divided by any number at all gives you a 0. So remember, the slope of a perfectly horizontal line is always 0. Now we'll do the same thing with vertical. We'll use these 2 points right here. The coordinates -3, 2 and -3, -2. Okay? In y2 minus y1, here's x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. We would get -4 over 0. Remember, you're never allowed a 0 in the denominator. So the slope for a vertical line, as a reminder, is undefined because you will get a 0 in your denominator every time you do the slope formula for an x equals equation. Okay, and that's a reminder now not only of how to graph, but how to find the slopes for horizontal and vertical lines. Okay, so I believe, short of that story problem there, let's see, give me a second, please. Okay, so actually that's it for the lesson. Because I'm not there, we are going to forego the story problems. Main idea is that we can graph slope-intercept equations and we can get them from one form to slope-intercept. Okay, and then this is your homework. In the book, no IXL. At least I don't believe so. See you guys.